the electron volt comes from this idea that we've already gone through, right? Work equals Q delta V. Work equals charge times potential. Okay. The electron volt is defined as how much energy an electron would gain if you allow it to move through a potential difference of 1 volt. So it's defined as the amount of work is the same thing as energy. The amount of energy that 1 electron would gain in moving through a potential difference, delta V, of 1 volt. Let's do that next. So this gives us an EV, electron volts, right? But we need to figure out a conversion from joules to electron volts. Understand, electron volts is a measurement of energy or work. Joules would be the base unit for that. Okay, joules would be the base unit of energy. We can use electron volts because lots of times, whenever you're dealing with subatomic particles, it's so much easier like this, right? 1 electron, 2 electrons, 3 electrons. Now, if we do this with coulombs, right? Work equals Q delta V. Let's put that back over to energy. The energy gained by an electron, that's 1.609, so 1.6 times 10 to the negative 19 coulombs, right, is the charge of an electron, times 1 volt. That would give me an energy of 1.6 times 10 to the negative 19 joules. Those two are equal to each other. No. This is the only reason I'm using 1 volt here is because of the definition of the electron volt, right? It's how much energy an electron would gain when passing through 1 volt. Okay. A volt is the amount of energy, it is kind of the opposite, the amount of energy you gain per unit charge. Potential energy per unit charge there. So they're not exactly equal to each other. You've got this charge idea that you got to throw in there.
It's like the volt that passes through like an electric field. Like where's the voltage energy from?
It actually gets it from the charge itself, dealing with electric fields. Yes. Okay. Now this is the conversion factor that you can use here. Now, a few thoughts for you. Kilo, I have 25 kilo electron volts. Kilo means what? Times 10 to the third. 25 times 10 to the third electron volts. And that's a measurement of energy, right? That's a measurement of energy. If I have 28 MeV, what's that capital M in front stand for? Mega, and mega is what? 6. Good, so this would be 28 times 10 to the 6 EV. If I need to get any of those electron volts over to joules, for example, the reason that I'd want to do something like that, let's say they ask what is the velocity of an electron or a velocity of some particle that has kinetic energy of 28 mega electron volts. Well, kinetic energy equals 1/2 mv squared, right? So the energy that I have to plug in, if I'm plugging in this in kilograms, something in kilograms, for example, mass of an electron, 9.11 times 10 to the negative 31st kilograms, that energy that goes for kinetic energy there, it has to be in joules, right? So I might have to convert from, let's say, 28 mega electron volts over to joules so that I can plug in to get the velocity. This is just conversions. It's a piece of cake, right? I need to go from electron volts to joules. Well, 1 electron volt is 1.6 times 10 to the negative 19 joules. Put electron volts on bottom and joules on top, right? Standard conversions, dimensional analysis. The electron volts would cancel. You multiply across 28 times 10 to the 6 times 1.6 is 10 to the negative 19. You would take that answer, and that's the kinetic energy. Right? Questions about that idea right there? Questions about that idea?
By the 1.6 and then answer.
Yeah. 1 eV equals 1.6 times 10 to the negative 19 joules, right? So if you go from eV to joules, you multiply by 1.6 times 10 to the negative 19. If you go from joules to eV, divide by 1.6 times 10 to the negative 19. Okay? And that'll let you get back and forth between those. That'll let you get back and forth between those. I don't remember if I actually worked all the way to velocity. I think I got cut off Wednesday whenever I was trying to get all the way down to velocity. So let me work that out for you. And let's do it starting in electron volts. So I got a big charge guy here, right? And he's putting out potential difference, right? There's an electric field, so we have equal potential lines, right, all the way around. So let's just say this is 50, 40, and let's make this exact, 40 volts, 30 volts. Okay? Now I'm going to take an electron. Let's take a proton. Why not? Take a proton here. And I'm going to release it. Right? I've got a big positive charge over here. I'm going to release it. I'm going to allow it to move over here to the 30 volt spot. I'm going to let it move out. Okay? And my question to you is, what is its velocity whenever it's out there? Okay, what is its velocity whenever it's out there? Well, work equals negative Q delta V, right? Work equals negative Q delta V. Let's start with that part, and I'll kind of show you where we're going in the end. Right? Work is the same thing as kinetic energy. Change in kinetic energy. Negative Q delta V, right? And then where we're going here, kinetic energy is 1/2 mv squared, right? We're going to take the kinetic energy we saw for here and plug it in down there. Okay, that's the idea. Now, where the electron volt, you can do this in joules very easily. Plug it in. We're at the charge of an electron, 1.6 times 10 to the negative 19, right? Change in voltage will be 30 minus 50. All right, 30 minus 50, final minus initial, and then plug it in. I want to work this in electron volts, though. I want to work this in electron volts, just for the sake of reminding you of all this. So I've got change in kinetic energy is going to equal. Okay.
Can you solve it in joules and transfer it to electrons?
We're going to actually have to transfer it back into joules. This equation over here, this is a joules only equation. Okay. 1/2 mv squared. The kinetic energy that we learned in the mechanical section is a joules only. Okay. Part. The electron volts are very useful for these problems, but not so useful whenever we get to using the kinetic energy equation. Okay. Good question. So this becomes negative. Now, how many electrons is one proton worth? 1. Right? So this is negative and then 1 for the charge. Delta V is final minus initial. That's 30 minus 50. Right? 30 minus 50. Okay? So this becomes delta KE equals positive 20 electron volts. Whenever I'm trying to deal with electron volts, instead of joules. And you can pick which one you so choose, right? The charge here, instead of using coulombs, the actual charge of the thing, just use how many electrons it is or how many protons it is. Number of electrons, number of protons, because an electron is worth the same thing as a proton. Okay, there's one's positive, one's negative. So I made that positive 1 proton. Okay? 1 proton times my potential difference, right? It went from 30 to 50. Gives me a kinetic energy of 20 eV.
Where'd you get the
Oh, good question. This, I kind of skipped a step here, right? This is -1, a negative out in front, times -20, right? That gets me over my positive 20 eV. Now I can't plug that into the other equation. Now we're to the point where number 11 in the homework is. Okay, I've got a kinetic energy in electron volts. Okay, they didn't make you do this part for that problem, but I've got a kinetic energy in electron volts, and I need to use this equation over here to be able to get that velocity. So the first thing I've got to do is I got to get this out of electron volts and into joules, right? Now, if this was mega electron volts, like I think the homework is, this would be 20 times 10 to the 6 electron volts, right? Here, it's not mega, I can just run with it as is, right? I want to go from 20 eV into something joules. Good. 1.6 times 10 to the negative 19 goes on top. 1 eV goes on bottom. And you solve from there. You solve from there.
I have a question. With the math, we